Hi, this is Dr. Kurt Wohler for Autism Recovery 101. This is Module 3. The topic tonight is how to interpret the organic acids test from Great Plains Laboratory. So this will be an interesting talk. For years, I have promoted the use of the organic acids test from Great Plains as a primary tool to assess for yeast, bacterial problems, other metabolic imbalances that are quite common in kids on the autism spectrum. So it's something that you as a parent or caregiver should know how to use, what some of the markers mean, and I'll go through some scenarios here of what really is a priority and what markers maybe don't mean all that much, particularly when they're just barely high. So we'll talk about the organic acids test in general, the role of the OAT. So the OAT, for our terminology, is the organic acids test. The OAT in Candida, Clostridia, and oxalate assessment. I'll describe what those are. And then looking at neurotransmitter imbalances as well, which can affect mood and behavior, attention problems. Some markers of vitamin need and fatty acid imbalances. And then we'll do a short discussion on mitochondrial dysfunction, which is an important thing to know about because that too can affect your child's energy, their physical stamina, their overall health. Okay, so the prioritization based on any given organic acid test is to understand it is a complicated test, but many of the markers really just indicate a potential problem in certain areas. Not all of the markers on the OAT indicate a problem that demands immediate attention. In fact, some of the markers will correct when you deal with some of the bigger problems like yeast issues or bacterial problems, etc. So the goal really is for you as a parent or caregiver to become proficient at reading the OAT, really with regards to your child's particular situation. Now, there are a number of documents in Module 3. So the first one here, the clinical significance of the organic acids test. This is a marker interpretation handout that comes from Great Plains Lab. This is sometimes what a doctor will use. When a marker comes back that they haven't seen before, they'll go to that reference guide and read about it. So that's worthwhile having. In Module 3, there's a sample organic acids test. We're going to go through that sample in the question and answer session that will cover the first 3 modules here of this course. The other handouts, this quick assessment guide, I'll show you what that is. That's just a handout that you can use as, again, a quick assessment of the commonly seen markers that are seen in autism, things that are generally high, kind of give a rough estimation about the percentages of when those are high. And then the last 2 are the mitochondrial assessment at a glance and the mitochondrial cocktail options. That'll fit into this mitochondrial talk, which we'll have shortly. As usual, you'll have access to the lecture slides in PDF form and the lecture slides in a note-taking form that you can use to take notes. This was the document I mentioned, the clinical significance of the organic acids test. Worthwhile having, print it out, download it to your computer, put it in a folder, just have it readily available. It's not like you're going to read through this thing, but it gives you a quick snapshot of a specific marker and what are some things that can cause it to be elevated. This handout is very useful. This is that quick assessment guide of the most commonly seen markers in autism that are found on the organic acid test. And so this is something that you definitely want to have with you when you are going through your child's test. Now, the example slides I'm going to be showing over the next 8 or 9 slides are off of a specific lab test. And I just want to touch on a few things, and we'll kind of expand on these throughout the lecture. The first thing that I look at on any given organic acid test on page 1 is the first part of page 1, top of the page, which is the yeast and fungal markers. The marker that most commonly shows up when Candida is a problem is number 7, which is arabinose. And that is specific for the presence of Candida. At times you will find some of these other markers high, but there's many situations where just the arabinose level is high. We'll talk about what are some behaviors associated with that shortly. Number 2 and number 4 are often elevated when there's been exposure to mold. Most common sources of mold are food. Moldy fruit, cheese, grains, for example, would be mold sources that we're exposed to, and most of the time when they show up, they're modestly high. The bottom of page 2 is the next section that I go, and my eyes immediately go to number 16 and number 17. These two markers, when they're elevated, are linked to the presence of specific types of Clostridia bacteria which produce these toxins, and these toxins can interfere with brain chemistry or nervous system chemistry that can lead to irritability, agitation, in extreme cases, aggression, sometimes self-injurious behavior. Sometimes 15 or 16 might be present as well. All of these things can indicate an imbalance in the digestive system, but it's the 16 and 17 which draws my attention if those are high as a priority of where to intervene. Now we'll talk about intervention for many of these issues in Module 4. The oxalate section on page 2 at the top of the page is the next place I look. I want to see if the oxalic level is high, and I'll explain what oxalates are here shortly. At times it's normal, sometimes they're mildly, sometimes they're very high. Oxalates can contribute to behavioral problems too, usually on the irritable, agitated side of the equation, okay, because small levels of oxalate form crystals, and these crystals can be irritating. They can get into the joints, the connective tissue of the body, they can create mineral imbalances, and also they can create pain on urination in some individuals. The bottom half of page 2 is where we start looking at metabolism at the cellular level. Now, glycolytic has to do with glucose metabolism, sugar metabolism, and then these two mitochondrial sections. What you'll commonly find is that when some of these markers are high, they're usually high, just mildly or moderately, in association with other things. Yeast might be high, Clostridia markers might be high, or oxalate levels might be high. A low value like number 28, by the way, is really clinically insignificant. It's really when they're elevated, it's most of an issue. The neurotransmitter section is very important on the bottom of page 2. When Clostridia markers are high, sometimes this homovanillic acid marker can be elevated, which can indicate too much dopamine production in the body. Too much dopamine can be stressful in the brain and nervous system. It can lead to irritability, agitation, hyperactivity, as well as aggression and self-injurious behavior in more extreme circumstances. Serotonin, this marker right here we'll touch on shortly, is most commonly low to low normal in honestly most everybody that's tested. On page 3 is pyrimidines and fatty acids. This first section is linked to the methylation cycle, which we'll get more into later in the course. The one that shows up most commonly when it is elevated is uracil. Sometimes it's just slightly 18 or 19 on the scale. And that is linked to a need for additional what's called methylfolate supplementation. By the way, methylfolate, along with methyl B12 in small amounts, are actually part of the Spectrum Mate supplement that is advocated with regards to the starter packet. These ketone and fatty acid sections, most of the time they're normal. When they are abnormal, sometimes they're just slightly high, and that's often associated again with yeast or bacterial problems. Sometimes these things just self-correct when you treat the bigger issues. The nutritional markers is an interesting section. You'll notice that in many cases the ascorbic acid level is low. Now that does not mean that there is a deficiency of vitamin C. Vitamin C or ascorbic acid gets metabolized very quickly in the body. So the level of it it goes away pretty fast. But it doesn't mean that there's a tissue or organ deficiency of ascorbic acid. But additional vitamin C could certainly be worthwhile. Many times we see low levels of B6, particularly when the oxalates are high, for example. This marker where we see an elevated glutaric, it's usually mildly elevated, 1.5, 1.7, 1.9. And it is associated often with the presence of candida. So it seems to coincide with that. The indicators of detox is on page 4, and many of the tests that I see, this is completely normal. What you'll often find, though, when glutathione is deficient, glutathione is a very important antioxidant in the body, and it's necessary to protect our cells against toxins, and many kids on the spectrum tend to have a problem in making enough glutathione. But when that's the case, the most common one that's elevated is pyroglutamic. Okay, it'll be elevated. Again, that doesn't happen that often. And I'll talk about the 2-hydroxyhyperic towards the end of the discussion. And then finally, at the bottom of page 4 is the amino acid metabolite section. This is the oldest part of any organic acid test. It's really there to pick up on serious metabolic disorders. If there is a marker that's high, sometimes it's just 1 or 2 that are mildly elevated. And many times they kind of correct with treating some of the bigger issues of yeast or bacteria. And then phosphoric often is normal. Sometimes we see it low to low normal, which seems to correlate fairly strongly with a need for additional vitamin D. So I'll talk about that towards the end as well. This page is just an indicator of fluid intake. This is an indication of how the test is analyzed. The reference ranges for male, female, greater than 13, less than 13. Some people will look at this page and look down at this marker down here where it says HPA is high at 3,800 plus and assume that that's their child's level. That's not. This is just an example of the report format. The test does give this image here that lets you know what are many of the different chemical reactions that are occurring within the nervous system. This essentially is a nerve cell. So it looks at tryptophan and dopamine, etc. And then every lab is going to come with an interpretation page. Here's the key point I want you to understand. If a marker shows up abnormal on the test, even if it's 1 point above the reference range or 1,000, they're going to print out essentially the same paragraph or paragraphs related to that marker. Okay, so it'll talk from everything about the fact that it's really not a big issue to it could be associated with some type of genetic disorder in certain circumstances. But you got to realize that the severe genetic and metabolic disorders are when the values are extremely high for some of these chemicals, and that is pretty rare. Now, we do have a website called Lab Test Plus at labtestsplus.com. This website allows access to many of the labs from Great Plains Laboratory, including the organic acids test, hair testing, stool testing, other labs as well for saliva testing. So if you would like to use that website, you certainly can to order some of these labs. And when the lab tests are sent to us, we'll actually do a written review of that lab for you to go over the more pertinent markers and what are called action steps and things that can be done to implement with regards to supplement strategies, etc., based on the lab markers. So let's get into the talk here a little bit. Let's talk about yeast candida. So remember, the first page of the organic acid test is looking at candida toxins, and then the most common one is arabinose. Now, it's quite common, okay? Matter of fact, many kids on the autism spectrum tend to have high levels of yeast, and this data goes back many, many years. This is an article that came out in 1995 that was looking at 2 brothers with autistic characteristics. where they looked at their urine to determine if there was some type of metabolic or biochemical imbalances. Now, this particular slide is representative of an individual who was not autistic. Now, you see that there were certain things that were slightly elevated, but none of us are going to be completely clear of all of these chemicals. But when they compared it to the autistic individuals, it was quite significant. The autistic individuals had much more biochemical imbalances that were determined. And as time has gone on, they've been able to determine what some of these chemicals do. Back at that time, it was some of the things were just isolated and analyzed, but they couldn't necessarily correlate with certain behaviors. In 2000, there was more research that was done. This was from Dr. Shaw from Great Plains Laboratory, where they analyzed control infants, okay, and they looked at control male children and autistic children of the same age. Control meant they were not autistic. We all can have candida, and that means we all can have a certain level of arabinose in our system at any given time. It just turns out that the autistic individuals tend to have a lot more of it, and what I've always felt is they tend to be more sensitive to the presence of candida in the body. And what's happening is if you look at our digestive system, we all have a good level of, or should have a good level of good bacteria that competes with some of these bad bacteria and keeps things in checks. And so we may get a little bit of yeast byproduct that filters into the body and it is dumped into the urine through the kidneys. But let's say after an antibiotic, we tip the scales. Now we've eliminated a lot of the good bacteria, and now we're left with more opportunistic bacteria and a lot more yeast, and now the yeast are producing a lot of these toxins, and that is then being detected in the urine, which is exactly what the organic acid test is doing. Now, Candida is a very complex organism, and it can be difficult to eradicate. And the reality is thinking we're going to get rid of Candida 100% is just not reality. There's always going to be a certain aspect of it that's part of our natural world, and our internal digestive system is part of the natural world too. So what we're really hoping to do is to gain control, or at least have a balance of good bacteria immune function to keep the yeast in check. But Candida can produce different enzymes that break down or start to break down the surface of the digestive system at a microscopic level. And that breakdown can be measured through arabinose. So essentially what arabinose is showing us is that there's some invasive nature of Candida. We don't know how many Candida are doing it, at where in the digestive tract it's happening. We just know that it's happening, at some level. And so the arabinose, in many regards, is an indirect assessment of the invasiveness of Candida at the gut level. But from a therapeutic standpoint, oftentimes using different types of antifungal medications can have profound effects. This was an article from the journal Discovery magazine back in the early 2000s. And all they did was give this child a month's worth of something called Sporanox, which is a systemic antifungal medication. And just look at the handwriting. Before the yeast treatment, very messy, hard to read. Afterwards, printing within the lines, very good penmanship. So what are some observations that are seen clinically in practice that, at least in part, appear to be related to Candida overgrowth? Well, sugar and carbohydrate cravings are often intensified in people who have a lot of Candida problems. Now, a lot of kids tend to like sugar and carbohydrates anyway, so it's hard to say that it's all due to yeast, but that's something that's certainly seen with adults as well. Some other things kind of unique to the autism community, though: heightened sensory-seeking behavior, self-stimulatory behavior, anxiety, emotional instability has been associated with Candida, and then kind of strange behavior, seeking pressure or hanging upside down off of furniture. Some kids actually having a heightened seeking out of masturbation. But the more common scenario that you should be aware of is the silliness, the goofiness, the giddiness, the inappropriate laughter. But this is not an interactive silliness, goofiness, giddiness. This is kids withdrawing or regressing and being silly, goofy, and giddy within themselves. And it's something that's more of a continual thing, not just associated, for example, watching something funny on TV. Now, many parents will actually describe it looks like their kids are drunk. They act drunk when their yeast levels are high. At least some of them do. And this makes sense if we look at what's going on at the molecular level within Candida. Glucose is sugar, and so the preferred fuel source for Candida is glucose. And if you just follow this little chain reaction around, the byproduct of this reaction is ethanol, which is alcohol. So it shows that Candida has the ability to produce alcohol as its byproduct of glucose metabolism. And there are people that have been accused and actually let off when they found out it wasn't the case of drunk driving or public drunkenness because their body is producing a lot of alcohol coming from their digestive tract that has an overgrowth of yeast and bacteria. It's called auto-brewery syndrome. Well, if we switch gears and think about some of the bacterial toxins, specifically the Clostridia toxins that I had mentioned before on the organic acid test, the 4-creosol and the HP-HPA. These can come from Clostridia bacteria. 4-creosol actually comes from Clostridia difficile, whereas the HP-HPA can come from a number of different Clostridia. And what they do is they can inhibit this specific enzyme, which helps us to break down dopamine and convert it to norepinephrine. Now that's important because norepinephrine in the brain is very helpful for attention, focusing, memory formation, just overall functionality of the brain with regards to focusing, etc. And then we know that too much dopamine, if this enzyme reaction is blocked, we're going to get an increase in dopamine. Well, that can create problems as far as causing some toxic stress in the brain and nervous system. Just like the yeast issues seen with autistic kids, where we find that a lot of the autistic kids have elevated levels of Candida, sure enough, the Clostridia seems to be highly represented in this population as well. Now, and that's evidence here by this study that looked at the HP-HPA marker. I mentioned about excess dopamine, and this is a confusing chart, so let's just kind of look at it, at face value here. One of the things that happens with dopamine is that it can generate what's called a lot of free radicals. This is oxidative stress, things that kind of are irritating and to the cells of the body, to the brain and the nervous system, and so that's not a good thing. Okay, so excess dopamine can generate a lot of oxidative stress, and in part can actually contribute to the depletion of glutathione, which we know we need to help protect our cells against toxins. Turns out that also dopamine, when it's elevated, can infiltrate the brain and nervous system. This image here of the parasympathetic and sympathetic is what's called the autonomic nervous system. It works automatically to keep our body in balance. And many kids with special needs tend to live more on the sympathetic side of the equation than the parasympathetic, where they have this fight or flight response, high anxiety, high stress, hyperactivity. And I realize not all of them have that, but many do. Physically, they might have dilated pupils. They may have really poor digestion, okay, where they're just not absorbing things effectively, or they tend towards constipation. Accelerated heart rate may be another example. And so the dopamine actually infiltrates and just overstimulates this sympathetic fight or flight response. And that also can then manifest as anxiety and severe cases, obsessive compulsive behavior. So the balance of the brain and nervous system is really an interaction balance between serotonin, between dopamine, between norepinephrine. We have to have a healthy level of all of these because there's actually crossover that occurs physiologically with how these chemicals work. It's not just about serotonin or it's not just about dopamine. Okay, let's switch over to the oxalate problem. On the organic acid test, remember this is page 2, first section of page 2 at the top, is oxalic or oxalate. And oxalates, or its acid form, oxalic, are organic acids that are found in 3 primary sources. The most common source is diet, but candida and mold can also contribute to oxalate levels. And then third on the list is that some kids have a cellular metabolism imbalance where they just don't process and break down oxalates very well, or they may overproduce them internally. In severe cases, there are some severe oxalate metabolic disorders, but those are not something that are commonly seen in most regular doctors' offices. Turns out that oxalic acid is the most acidic organic acid in the body, and so it can cause these small crystals that can deposit themselves in different organ systems. They can trap minerals in the body, for example, and they've been known even to trap heavy metals in the body. Now, most sources of oxalate are food. I do a lot of consulting work for a group out of China where I look at hundreds of organic acids tests. And this was one of the highest I'd ever seen. But I knew based on other factors in the test that this was a diet-related issue most likely because the child's yeast level was non-existent. And these other 2 markers here, even though this is in Chinese here, the 105 and 35, these are those those are the enzymes that help break down the oxalate. Those were not elevated, so this was most likely a food source coming out of China, most likely soy. Maybe there's spinach and other things too, but it's most likely a diet source. And if you look at these things under a microscope, they have this X-like configuration, this crystal formation, and you can see why this might be irritating to somebody. These sort of sharp, jagged edges here, getting into the connective tissue or trying to urinate these out might be irritating to the bladder or the urethra of a boy or girl, or a man and a woman as well as adults. Now, the metabolism of oxalates, like a lot of the biochemistry, can be a little confusing, but if you just sort of focus on the big issues, the main source of oxalate exposure for most people is diet. Okay, so soy, spinach, nuts, nut butters, berries, berry juice tend to be fairly high on the oxalate list. And we'll talk more about oxalates when we get to the module on diet. I also mentioned candida. Candida, in addition to some of the other enzymes, also produces an enzyme that breaks down collagen. Collagen is what helps make up the connective tissue and the skin, etc. And so that can break down and feed into this oxalate pathway as well. So what are some common complaints and observations? Well, a lot of parents will talk about their kids having sandy and grainy stools when their oxalate levels are high. Bladder irritability, pain with urination, children, a little boy holding the penis or a girl holding the groin area, being irritated when they urinate, that can be a sign of oxalate issues. Sometimes pressing the groin up against a piece of furniture or on the floor to try to relieve some kind of discomfort might also indicate an oxalate problem. One of the reasons we recommend calcium after going off, or when you take your child off of dairy, for example, is because many kids are calcium deficient, but calcium can also be complexed with oxalates in the body, and it can cause eye pain. So when there's a calcium deficiency, it has been associated with eye pain and in some extreme cases, poking at the eyes. Body aches, burning feelings in the muscles, moodiness, irritability, aggressive behavior. I realize that I can't say that moodiness, irritability, and aggressive behavior is strictly related to oxalates, but oxalates are one of the things that can lead to that. So that's why testing is important through the organic acid test. Now, if we change focus here, let's talk a little bit more about brain and nervous system imbalances. I mentioned before that the serotonin marker tends to be low to low normal. Okay, and that's fairly common. Serotonin is important for mood, for sleep, because it gets converted into melatonin, fine motor skills, gross motor skills, etc. And what you'll often find is that the serotonin marker is low to low normal, but we've got a slightly elevated quinolinic to chynurenic acid ratio. What that means essentially is that there's a trend that is occurring where we're not getting enough conversion of this amino acid called tryptophan into the serotonin pathway, and more of it's sort of being peeled off into the quinolinic acid side of the equation. Quinolinic acid is a natural chemical in the body, and it's important to help the cells make energy, but too much of it can be stressful to the brain and nervous system too. It can be overstimulating. And so if it is elevated, generally you want to try to at least block the body's production of it in excess. It's commonly elevated, by the way, like in these scenarios where you see quinolinic at 7.7 or 14. Oftentimes this is the case when there is bacterial infections present. So some type of infection is driving that problem. By the way, in all of the organic acid tests I look at, it's not very common to see elevated quinolinic acid by itself. So the chances are, in your particular circumstances, it's not likely going to be high. But quinolinic acid is something that's important to understand, and I'll talk shortly about what is done to kind of help remedy it, because really what you're trying to do is get at the things that are known to cause it to be high, which can be yeast, which can be bacteria, which even can be stress. Okay, so stress and cortisol can cause the quinolinic acid to be elevated too. Let's focus now on mitochondria and the role of mitochondria, and some take-home points, because mitochondria and mitochondrial dysfunction is fairly common in autism. And really, mitochondria are the energy factories of our cells. They produce this energy currency called ATP, which runs all of the machinery of our body. So our heart, our brain, our nervous system, our immune system, our muscles are all based on this energy currency of ATP that comes from mitochondria. And there's a lot of biochemistry involved, but one of the things that can happen with candida and with oxalates and with Clostridia bacteria and other toxins is that various steps in these biochemical chain reactions can be altered, sort of like a factory, right? If you break down the factory at one step, you might inhibit the production of a certain product that factory is trying to make. Same thing happens in our body with regards to mitochondrial function. Most of the time that when these markers are high, they're just slightly high. So for example, this malic acid, just 2.4, reference range 2.2. But sometimes we'll find some other markers fairly high. Okay, citric acid is quite high in this case, and succinic acid is quite high as well in this particular case. And so the higher the level, and I can't give you an exact cutoff, but the higher the level, potentially more of the problem. For example, succinic, rough estimates are that perhaps levels above 50 might point to a more significant mitochondrial issue. And what's being discovered, by the way, with regards to the succinic is that it seems to be strongly correlated to chemical exposure of some form or another. Great Plains Laboratory has something called the GPL tox screen. This is a urine test that looks at environmental chemicals, and invariably what you'll find when the succinic is high sometimes is you'll find chemical exposure to, say, gasoline additives, which are pretty common for anybody living in or near a city. There's also a marker on the GPL tox that is a strong indicator of mitochondrial dysfunction, and it's called Ti-glyglycine. So Great Plains carries this test that can be added on when ordering the organic acids test to be able to determine, is your child being exposed or have been exposed to certain environmental chemicals that could be compromising their health as well. One thing to keep in mind too with regards to mitochondrial function is oxalates. Oxalates have the ability as well as candida, as well as Clostridia bacteria and the toxins it produces to interfere with how the mitochondria produce energy. So you'll often hear about mitochondrial dysfunction, and sometimes you'll hear about mitochondrial disease. So it was once thought the mitochondrial disease to be fairly rare, but it's really becoming more of a common metabolic problem in kids. Some cases of mitochondrial disease do occur in autism. Now, these are usually brought on by more serious genetic mutations or serious abnormalities in the way the cells metabolize substrate in the body. And in many cases, there's very serious health problems associated, okay? Heart defects or serious brain abnormalities like seizures or strokes or severe gastrointestinal problems, and then, balance and coordination issues. But the vast majority of kids who have a mitochondrial problem is usually what's called a dysfunction. Okay, this is where we're just getting suboptimal function of the mitochondria, usually brought about by other factors, toxins, yeast, bacteria, oxalates, maybe some nutritional imbalances that are occurring. Okay, but they're not a definable mitochondrial disease. In fact, one study looking at autistic kids showed that even on when they did muscle biopsy testing, which showed no evidence of mitochondrial disease, these kids had attention and language and behavior problems. They had seizures, poor muscle tone, gastrointestinal, what's called motility problems, things that are common with the mitochondrial diseases. The autistic kids had them as well, but they didn't have any evidence of testing that to confirm that. And the reality is that the difference between mitochondrial dysfunction and autism and true mitochondrial disease is the severity. The dysfunction is just less severe than classic mitochondrial diseases. And so research has looked at why this might be occurring. Okay, and there's a lot of speculation. Certain things are proven out. Environmental chemicals, which I just told you about, that can be picked up from that GPL tox test. Heavy metal toxicity. In some cases, vaccine reactions have been associated with this. And then other things, the oxidative stress. We talked about glutathione that sometimes is low. Nutritional imbalances. Anything that could just affect the normal function of the mitochondria at the cell level. One other thing about Clostridia bacteria I just want to point out, amongst all the other things it can do, is it can also produce a chemical called propionic acid. And it turns out that propionic acid coming from Clostridia can also interfere with mitochondrial production of this energy chemical called ATP. Because what it does is it infiltrates itself into this thing called the Krebs cycle and slows down its function. So as you can see, really what we want to do is be able to get after those major players, which is the bacterial problems, the gut problems, the yeast issues, etc. Now, there are a number of different labs, but I can tell you the biomarkers that get picked up on the organic acid test are quite helpful to help define a mitochondrial dysfunction. In order to define a mitochondrial disease, you'd have to go through more specialized testing with a metabolic specialist. Sometimes they have to do muscle biopsy testing, etc. But vast majority of kids, if they do have a mitochondrial problem, it's more of the dysfunctional state. This handout that you have in the document section called Mitochondrial Lab Assessment at a Glance is just that. This helps to explain this section a little bit more and where to prioritize things with regards to certain lab markers, and then what are some things that can be done to just support mitochondrial function. Most of the supplements, even when you go on a starter pack, even adults going on a multivitamin, multimineral, or antioxidant will be supporting mitochondrial function because it uses things like B vitamins and antioxidants and another nutrient called L-carnitine to help improve the way it functions. And then we have these things called mitochondrial cocktails, which is just a combination of different remedies, different supplements that support mitochondrial function. So you could make your own cocktail. There's not one specific cocktail. It's just sort of a term that's used. And so I created this handout called the Mitochondrial Cocktail Options. And this just talks about a few different supplements that are useful that have very targeted mitochondrial activity, specifically L-carnitine and CoQ10. These are pretty common supplements that are often used to support mitochondrial function. Carnitine helps to get fat into the cells to be used as a fuel source. CoQ10 has an effect at really boosting the mitochondria's ability to produce that energy currency chemical called ATP. A real convenient way to dose this quote-unquote mitochondrial cocktail is this product called MitoSpectra. Now, MitoSpectra was actually developed for individuals or children with mitochondrial diseases to support mitochondrial function, but it's also useful, again, in mitochondrial dysfunction. It's got a little bit of vitamin C, vitamin E, some B5, L-carnitine, and CoQ10. And this is available from New Beginnings Nutritionals, which we've discussed before. And you can actually get the dosing recommendations right off the webpage. And in fact, the dosing recommendations are also incorporated into this handout, the mitochondrial cocktail options. They basically dosed on age and weight. So a pretty simple, straightforward product to add in as a complement, if you will, if some of those mitochondrial markers are elevated. A few other sections on the organic acid test, this ketone and fatty acid section. Most of the time when these things are high, they're just slightly high. This can indicate that there's perhaps a little bit of sluggishness in the way the cells are metabolizing and burning fat for a fuel source. A lot of times just some carnitine, 500 milligrams to 1,000 milligrams, can be helpful. At times, though, there are situations where these markers can be quite high. This happened to be a child out of China that I saw. And when I saw this, I was quite alarmed because I thought, well, some of these are quite high. But what it turned out was this child had been on high-dose medium-chain triglyceride oil, what was called MCT oil. Parents were using it to treat yeast, which actually comes from coconut. It doesn't mean that this person had to stop it entirely. I think cutting back on it was useful. It just meant that the cellular system was being overwhelmed a little bit, couldn't keep up in trying to move this fat into the cell to burn as a fuel source. So cutting back on the dose was helpful, and also incorporating some L-carnitine to help in the process was useful, but it was not indicative of a disease process. It just indicated more of a dysfunction because this child had been on this supplement for quite a while, and it was just kind of overwhelming their system a little bit. So that's another reason to often retest with the organic acid test too. You know, usually, ideally a couple times a year as a general maintenance. If you're actively treating an infection, we'll talk about this more in Module 4 with regards to the treatment, then you might want to come back a little bit sooner, sometimes a couple months after initiating antifungal or bacterial treatment to see if the levels are normalizing. The vitamin indicator section again, is a useful tool. We have these indirect markers and direct markers. The direct markers are ascorbic acid, pantothenic acid, which is B5, and then pyridoxic acid, which is B6. These are generally low when there's an indication of the need for more of that vitamin. These markers up here are elevated when there is an indication of the need of that nutrient. So for example, methylmalonic acid will be high when there is a deficiency of B12. These don't come back low all that often. The one that most commonly shows up is ascorbic acid, which I had mentioned before. Okay, low ascorbic acid, again, is not indicative of a true deficiency of vitamin C. It just may mean that a little bit more is worthwhile to use. The other one that shows up fairly commonly is glutaric acid. That's often elevated, mildly so, when yeast is present. We'll often see B6 levels low to low normal when oxalate levels are high. Okay, the methylmalonic, the CoQ10 marker, 3-hydroxy-3-glutaric, this methylcitric, if these are elevated, it indicates a deficiency of that nutrient. It's not, in all of the organic acid tests that I look at, they're not elevated all that often. So again, this is just a priority list of generally what's seen. Very common to see these first three show up even at low levels on most organic acids tests. Okay, I mentioned before the pyrimidine marker and the metabolites, excuse me. If these show up elevated, usually it's going to be uracil, and it's just slightly high, 20, 21, 22, for example. And that can indicate a need for more methylfolate. We're going to get more into that when we get into the methylation talk later in the course. As I mentioned, the methylfolate is actually part of the package of that starter packet with the SpectrumMate supplement. Now, this marker here, the 2-hydroxyhyperic, something to pay attention to. When I do see it elevated, it's usually low normal, about 1.4, 1.6. That's often associated with just foods, certain foods like artificial colors or flavors. Aspartame can cause it to be high, NutraSweet, for example. Tylenol use or paracetamol use for fever control can cause it to be elevated. Sometimes it comes because of bacterial levels. In this particular case, the level was quite elevated. It came from aspartame use. Okay, so this level was quite high. Notice this is a fairly common level to have it elevated. 1.4, 1.6, 1.8. Okay, generally indicative of either bacteria or some other type of substance in the diet. If you see things where it's coming back really, really high, then I've often found that associated with some type of food consumption. Again, NutraSweet or aspartame is kind of a classic example. This amino acid metabolites, just to recap, okay, it is the sort of the oldest part of the organic acid test, looking at, it's really more for serious inborn errors of metabolism, these serious metabolic disorders. It's not significantly elevated in many kids at all. The phosphoric marker is interesting. You rarely will see it high. When it is high, it usually means there's some type of acidosis. And in those particular cases, and I've seen a lot of these tests, it really comes down to serious gut problems, a lot of bacteria and yeast problems, for example. But even with that, I don't often see phosphoric levels high. It can also come about from a person drinking a lot of soda pop. With soda pop has phosphoric acid in it. What's more common is to see a low to low normal value. And this seems to strongly correlate with a need for more vitamin D. We'd like to see vitamin D levels between 50 to 70 approximately as an ideal range. As you notice in this particular case, we've got a vitamin D level total at 21, so it's suboptimal, and our phosphoric acid level is low normal as well. I've seen this more and more now with more and more tests. Okay, so with that, the prioritization of the organic acid test really kind of breaks down. If Clostridium markers are high, so that HP, HbA, and or the 4-creosol is high, that really is a priority in my experience. That needs to be dealt with. Those bacterial markers need to be dealt with before you'll see much success in implementing other interventions off the organic acid test. If the arabinose or other yeast markers are high, it needs to often be correlated to the clinical picture of the child. Are they goofy? Are they giddy? Do they have a lot of self-stimulatory behavior? Do they act drunk, for example? If the oxalate is high, that again too needs to be correlated to the clinical picture. Does the oxalate associate with irritability or agitation, etc.? Because not every child needs to be on an extreme low oxalate diet. Just like not every child who has a slight elevation of yeast needs to be on some strong medication to deal with it. And reality is not every child needs to be on an antibiotic to treat bacterial problems. Usually the worsening of behavior would generally dictate how the intense or more assertive you become with certain therapies. But the key point of this, these three markers and these three sections I just talked about can radically influence other sections and markers on the organic acid test. So that's really where often the priority needs to be given. For example, if you do a test and you see a specific fatty acid marker is significantly high, or maybe multiple ones are high, then some L-carnitine supplementation can be worthwhile. But if the yeast is high, the bacteria high, and the oxalates are high, well, those also need to be dealt with too. And then you retest a couple months down the road and see where your levels are. If there are multiple mitochondrial markers that are high, you can consider mitospectra, for example. Not a bad way to go, and I've seen a lot of kids do fine with that. If the dopamine level is high, this HVA, for example, make sure the Clostridium markers are normal or high. Okay, if more times than not, if that HVA level is high on the organic acid test, more times than not, one of the Clostridium markers is also high because it's inhibiting that enzyme. Low levels of serotonin can often be improved with just 5-HTP supplementation modestly, 50 to 100 milligrams. That quinolytic acid marker I mentioned, you won't find it elevated very often, but if it is, I've seen good success with a product called niacinamide that helps to just sort of prevent or slow down the production of quinolytic acid. If the uracil is high, well, the implementation of L-methylfolate supplementation can be worthwhile. Other vitamin deficiencies, you can kind of treat it individually. Again, that vitamin C marker is commonly low. It doesn't mean there's a deficiency, but maybe 250 milligrams or so a day can be worthwhile just from a general health standpoint. The low phosphoric that I mentioned, which is the last marker on the organic acid test, seems to strongly correlate when it's low to low normal with a need for additional vitamin D. Now, there's an organization called the Vitamin D Council that recommends vitamin D supplementation at, and this is approximately, about 1,000 IUs of vitamin D3 per 25 pounds body weight per day. And that's a good ballpark for many people. So it's a good idea to test vitamin D levels a couple times a day, and that also is a test that comes from Great Plains Lab. We carry that off of the Lab Test Plus website too. And it's a finger prick test. It means it's a blood spot. It can be done at home. And that goal, again, is to try to keep the vitamin D somewhere between 50 to 70 ideally. And that really can help just overall with the immune function, health, and in some kids, they actually just, with vitamin D improvement, improve cognitively, because it's interesting, there's actually a relationship between adequate D levels, vitamin D levels, and serotonin levels. Okay, so that is the discussion for Module 3. So Module 4, we're going to get into treating yeast and bacteria and other digestive problems. So we'll go through some strategies, some different remedies that are used for these problems. We'll review more, again, the behaviors that are often linked to some of these digestive problems. As I mentioned before, in the question and answer session, for the first question and answer session coming up, we're going to go through question and answers and topics over these past 3 modules. We will also go through that sample OAT, that sample organic acid test. I'll go through that test as well. So to help reinforce some of the information you learned on this module. If you have any additional questions, questions on the website, accessing the material, make sure to reach out to us. You can go to utism+recovery+101+gmail.com. Thanks so much.